Greetings, everyone. My name is Chris Podos, and I'm here to present to you one of the greatest problems modern biology faces, as well as one of the most useful tools in our fight against this very issue. I am, of course, talking about the massive problem of the biological data produced that needs to be analyzed. In fact, our experts expect that by 2030, 25 petabytes of biological genomic data will be produced annually. That's 25 petabytes, 25 million gigabytes. That's an absurd amount of data. All is not lost, however. Our hope lies in amazing tools of computational biology. One such tool is a method called binary search, and we are going to talk about it today. Alright, so the problem of the massive amounts of biological data is a problem that many biologists face, even our youngest members. In fact, when I was an undergraduate biology student, I was tasked by my professor because he knew that I was a programmer. I was tasked to make a program that will take 11,000 picks, 11,000 positions in the petunia genome, and it will tell me if one of those positions was in a gene, and if yes, what that gene was. It needed to do that for every one of those 11,000 positions. Now, the petunia genome is massive, and a simple program for this job will take much time. To present this to you and this method called binary search, I'm going to use something my professor advised me to do. He told me when I had a big databases, big biological data uh, all in one space, to think about it like a book. In our case, we have the petunia genome, right? So think of the genome like the book and the chromosomes of that genome like the chapters and its gene like a different page. Here I have a book to show it to you. So let's think about it. I have a position, right? So I want to find a specific gene, a specific page, let's say page 300 in chapter 6. Now, a simple program would just start in the very beginning and just flip and flip and flip and flip until it found the right page. That would take so much time. In fact, I calculated it for my program, the one I needed back then. It will take more than 2 hours. That's so much time in today's science. So, of course, a much faster way was needed. I thought about it for a whole weekend and I figured out a program. So, I thought, what if instead of going from the beginning, flipping its page, I went to the very center and I looked at the chapter. Let's say here, I have opened in the center, I'm at chapter 9. Okay, so our chapter 6, that is uh, not as big as 9, is at the beginning of the book or at the end? The beginning, right? So I go here, I dispose of the other part, and I open this in the middle as well. I'm at chapter 4 now, okay? So is chapter 6 here or is it here? It's here because six is larger than 4. And I do the same until I reach my chapter. I open the middle again. Now, when I have the right chapter, the right chromosome, I start to look at the genes, at the pages. Uh, so, my my page is 300, and let's say I'm at 20, I'm 20, 250, okay. So my page, the page that I owned, is not in the beginning part because 300 is larger. It's here in the other part, and I split again in the middle, and again until I find my right page. I also have a mechanism that when the pages get real low, let's say 3 or 4, it just flips them one by one. That way, I avoid problems such as my page being the very first one or the very last one, because the very first or the very last one will not be our desired page no matter how many times we split, right? Okay, that method, that simple method of just going to the center and the center and the center of the center is called binary search. It's that simple, just going to the middle. But it saves me from so much time in fact, that do you remember how much time it took me with a simple flipping program? More than 2 hours, right? I'm glad you remember. Do you know how much time it took me with this program, binary search? 7 seconds. Do you see the difference? This means so much for our today's modern, ever changing and massive and international science. We need that kind of speed. We need it. And binary search is the foundation of so many tools that provide this speed for us and provide everything science provides for us today. It wouldn't be possible otherwise. I want to leave you with this message. I hope you understood the process. And it's very simple, isn't it? I did figure it out back then, and I'm sure many thousands of people have thought about it on their own. Of course, I didn't invent it. Sadly, it was invented back in the 60s. But it's amazing how such a simple idea can do so much for science. And this is what I'm going to leave you with. Everyone, literally everyone, you don't have to be a genius, can make a change in science, can show a different idea, something that no one has thought about before. But when you present it to them, they are like, yes, why? It's so simple. Because many things are simple until you think about it. So, my message to you is this: use logic to go forward, because you don't have to be the next Einstein, the next genius. Each and every one of us hides a scientist within them. Thank you.